So the next question is, if you have a linear system and you write down its augmented matrix, how can you choose a sequence of elementary row operations to make your augmented matrix become or take one of these forms, to actually be in reduced row echelon form? I shouldn't have pointed these. It won't necessarily look like exactly one of these examples, but you can always take an augmented matrix and you can perform a sequence of elementary row operations that turns it into reduced row echelon form. And that's going to be what we talk about next, is a guaranteed way to do that. Now, this won't necessarily be the fastest way to do it. It certainly won't be the only way to accomplish it, but this is something you have to fall back on that will always work. So this is called the Gauss-Jordan elimination method, and what it follows is I'm going to illustrate the algorithm now. So let's say that the following is an illustration of the Gauss-Jordan elimination method. So that's what we're going to do next. So I will slide this up now, and let's do an example. See what this looks like in practice. So I'm going to write down an augmented matrix which corresponds to a linear system of 4 equations in 6 variables. And this is just complicated enough that it really shows you what to do in general, what your strategy should be, but it doesn't get so complicated that we get bogged down in the details and lose track of the most important ideas here. So that's why we're using this one. So that's the first 2 rows. The first 6 entries are going to be the coefficients of the 6 variables. And then the 7th entry of each row will be the constant term, which really is the constant on the right-hand side of the corresponding equation. And then our last row, 2, 6, 0, 8, 4, 18, and 6. Okay, so let's look at what we can do. So your first strategy, or your first goal of this strategy, is going to be to try to get a 1 in the top left corner. And the good news is, in this example, it's already a 1. So that is already done for us. So we don't have to worry about making this into a 1. But the next thing you're going to look at is, once you have a 1 in the top left corner, it won't always be possible, but if it is, once you obtain that, your next goal will be to zero out all the entries below it. So what you're going to try to do now is turn those 2's into 0's. And now this is already a 0, but I've included it in these entries as well because these are the entries you're looking at. These must be 0. That's your next goal. These must be 0. Well, it's your first goal in this case because we already had a 1 in the top left corner. So how can you do that? Well, the idea is to use this 1 to accomplish that goal. So if I subtract the first row from the second row twice, that will turn this 2 into a 0. And I can also subtract the first row from the fourth row twice to turn this 2 into a 0. So that's going to be the operations we do for this first step. So we're going to take row 2, we're going to replace it with row 2 minus 2 row 1. And then we're going to take row 4 and replace it with row 4 minus 2 row 1. We're going to subtract the first row from both the second and fourth rows. So what will that look like once we accomplish that? So the first row won't change. Right? So let's start by just writing down the part that won't change. Our second row will change. So let's perform the arithmetic. If I go 2 minus 2 times 1, that's going to give me a 0. In fact, that's not a surprise, right? That's why we chose this operation, was to get a 0 here. Next, if I go 6 minus 2 times 3, that'll be 6 minus 6, which is 0. If I go negative 5 minus 2 times negative 2, that's really negative 5 plus 4. So this is going to turn into negative 1. Negative 2 minus 2 times 0, that'll still just be negative 2. If I go 4 minus 2 times 2, that's really 4 minus 4. So you're going to have 0. the -3 and the 1, or sorry, the -3 and the -1, they won't change. So we can just write those down. Our third row, well, that also didn't change because we didn't do any, it doesn't appear here as a row that's being overwritten, so we can copy that one down. But then row 4 will change, again, because we're taking row 4 and we're subtracting row 1 from it twice. So 2 minus 2 times 1, that'll be 0. Again, we're expecting these to turn into 0, so this is not a surprise. 6 minus 2 times 3, that's 6 minus 6. So then we'll have 0 minus 2 times -2. That's going to be positive 4 because it's like adding 4. 8 minus 2 times 0, that won't change. 4 minus 2 times 2, that's 4 minus 4. The 18 and the 6, if we subtract 2 times 0 from both of those, that's just subtracting 0, so that won't change the entries. So we're still going to have 18 and 6. All right, so that's what we get for those first two operations. So our goal at this stage was to turn these two non-zero entries into zeros, which we accomplished, right? That happened. But looks like we accidentally also turned these two sixes into zeros. Now that won't always happen, but it just actually just ends up being better if it does. It just makes your job easier. So now what you're going to do is just work your way over to the right and look at the first non-zero entry of each row. Remember, they have to be ones. If we're going to achieve row echelon form, the first non-zero entry of each row has to be a 1. Now, this one is the first non-zero entry of the first row. It's already a 1, so that's good. That's taken care of. But none of these three entries are equal to 1, and these are the first non-zero entries of the second, third, and fourth row. So what you're going to do is you're going to look at the very top one, and we're going to do whatever we have to do to make this equal to a positive 1. Now, the simplest way to do that, in this case, is just, why don't we multiply the entire second row by the constant -1, and that will have the effect of flipping the sign of all the non-zero entries. So that's all we're going to do in this step. So I just want to make it clear what our goal is. This must be 1. So we're just focused on a single entry here to make a change to. So let's do the operation. So we're going to take row 2 and replace it with -1 times row 2. So that's the only thing that's going to change here. Okay, so the first row will stay exactly the same. But the second row is going to change. Now all these zeros, multiply them by anything you like, they're not going to change. So the zeros won't change, but all these negatives will turn into positive numbers. So we'll have 0, 0, 1, 2, 0, 3, 1. The third and fourth rows won't change. So we can just safely copy them down. And don't be afraid to just do one step at a time. There's always a temptation to try to do as many steps as you can for each, or do as many operations as you can for each step, because it makes you feel like you're saving time. But I promise you, it really doesn't take that long to write this out. Once you get in the habit of doing it, you'll start to get faster and faster at it. And it gives you time to think, which I actually personally find very valuable. It gives you time to think about and process where you're at and decide what your next step should be. You can do operations. Sometimes you can do several operations in one step, like I did up here, right? But it's very important that they don't cause any conflicts with each other, right? Subtracting row 1 from row 2 twice, and then subtracting row 1 from row 4 twice, those two operations had nothing to do with each other. They didn't cause any conflicts. But I see a lot of people get a little too carried away trying to save time, and they end up creating conflicts between row operations that they do on a single step. And it's one of the biggest sources of errors for these problems. So I really urge you to, when in doubt, just do one operation per step. There's no harm in doing that. Okay, so what's next? Well, this non-zero entry, which was the first non-zero entry of that row, which was not equal to +1, is now equal to +1. And you might say, well, what about the 5 and the 4? Why didn't we just also take care of those in the previous step? We could have multiplied row 3 by 1/5, and that would have turned this into a +1. And then we could have multiplied row 4 by 1/4, and that would have turned this into a +1. And then we would have turned all these into leading ones. But that actually wouldn't be what we want to do. Because remember, we can't have leading ones stacked on top of each other, because the third condition for row echelon form is that every leading one must be to the right of every leading one above it. So this is a leading one, and this is a leading one that is above it. And this leading one is to the right of this leading one, and that is good. But if I had two leading ones down here, that would not be good. That would not satisfy the condition. So we're not going to turn these into ones. We're going to turn these into zeros, just like we did with the twos up here. Oops. Just like we did with these twos up here. This is what we're really doing, is we're working our way over to the right, one column at a time. So that's our next goal. These must be 0. So how are we going to accomplish that? Same as before. Remember, we used this 1. We subtracted appropriate multiples of row 1 from row 2 and row 4 to turn those 2's into zeros. We're going to do something similar here. We're going to subtract appropriate multiples of row 2 from row 3 and row 4 to make these into zeros. So let's take row 3, replace it with row 3 minus 5, row 2. And then we can replace row 4 with row 4 minus 4, row 2, right? Because that'll do it. If we subtract 1 from 5, 5 times, this will be 0. And if we subtract 1 from 4, 4 times, this will become 0. And that's what we want. So that's what we're going to do. So again, the first 2 rows won't change. So let's take a few seconds to just copy those down directly. Now the third row will change, right? And the nice thing about this algorithm is that since all these entries are all zeros, no matter what operations we do between the second, third, and fourth row, all these zeros will always just be zeros, right? No subtracting or adding of these entries to these entries will change them, because they're all zeros. So these are going to be zeros here. But now we're going to go do this operation for the rest. So 5 minus 5 times 1, that'll be 0. No surprise, because that's what we were hoping for, right? 10 minus 5 times 2, that's going to be 10 minus 10. 0 minus 5 times 0, that'll just stay as a 0. 15 minus 5 times 3, that's 15 minus 15, which is 0. And 5 minus 5 times 1 is 5 minus 5, which is 0. So actually, we just introduced an entire row of zeros for the third row. That wasn't really what we set out to do. Our focus was just with these 2 entries, but in this case, it just turned out that we ended up erasing this whole row, so to speak. It turned into all zeros. But let's finish the fourth row now. So what happens here? These will just stay as zeros, right? 0 minus 4 times 0 is still just 0. 0 minus 4 times 0 is just 0. Now we've got 4 minus 4 times 1. That'll be 4 minus 4, which is 0. 8 minus 4 times 2 is 8 minus 8. So that'll be 0. 0 minus 4 times 0. Got a lot of zeros here. This is good. This means this is working. 18 minus 4 times 3, that's going to be 18 minus 12, which is 6. And then 6 minus 4 times 1 is going to be 2. So that's what we get after that step.